Good evening all. Today we shall see topics on third module. So in this module we are dealing with the main parts of transmission system, need for transmission, etc. So what is meant by transmission system? Electrical transmission is the process of delivering generated electricity from generating stations. The power has to be transmitted over long distances usually. The load center as well as industrial areas may be far away from the generating station. So in order to distribute the power among various types of consumers, it is essential to transmit power. What is the need for transmission? Often the powerhouse and the load centers are remotely located. This makes a transmission network inevitable for a power system. When power is transmitted over long distances, high voltage transmission is opted to reduce the transmission losses in the form of I²R losses. In high voltage transmission, the current rating will be low and hence I²R losses will be minimum. We know that power is roughly the RMS value of voltage into RMS value of current. So when voltage is greater, in order to maintain the power a constant, current will be lesser. So by opting high voltage, we can reduce the current used for transmission, and the transmission loss depends on square of the current. So when we reduce the value of current, this I²R loss will be considerably reduced and the efficiency of transmission improves. So we go for high voltage transmission. Here we can see various parts of transmission. There is a tower on which the wires are being arranged. High voltage conductors are being arranged. This is a double circuit line. On both sides we are having the conductors. The ground wire is provided on the top. Then insulators are there. They are separating the conducting wires from the supporting tower. This is also another diagram of the transmission line. Tower is there. Then the ground wire acting as a lightning protector is provided on the top. This is also a double circuit line. On both sides we are having the power lines. You can see the insulators also which are separating the conducting wires from the tower. Advantages of high voltage transmission. With increase in transmission voltage, the current is considerably reduced. So the size of the conductors are reduced. Cross section of the conductor reduced as the current required to carry is being reduced. With the reduction in current, I²R losses reduces, hence results in better efficiency. Due to low current, voltage drop will be less because voltage drop is given by current into resistance. As the current decreases, the voltage drop will be less. So voltage regulation improves. Then limitations of high voltage transmission are: with the increase in voltage of transmission, the insulation required between the conductors and the earth tower increases. This increases the cost of the line support. With increase in voltage of transmission, more clearance is required between the conductors as well as between the conductor and the ground. Next, we shall see the one-line diagram of a power system. We are starting with the generator. Usually at the generator or powerhouse, the generators are located in the powerhouse. The power is generated at 11 kV. Then at the yard of the powerhouse itself, we will be having a substation where we are stepping up this 11 kV voltage to a higher voltage. So there is a step-up transformer in the primary substation. So the primary transmission starts from this substation. Here the 11 kV voltage is stepped up to around 220 kV voltage. Then from this substation to the next substation, we are having the primary transmission section Here the transmission voltage is at 220 kV. Then at the receiving station there is a step down transformer which steps down 220 kV to either 33 kV or 66 kV. Then we are having the secondary transmission. The voltage of secondary transmission usually will be 66 kV to 33 kV. Then from this substation, the power can be fed to a bulk consumer. Then the secondary transmission feeds a primary distribution substation also. Here the voltage is being stepped down. That is 33 kV or 66 kV is being stepped down to 11 kV by a step down transformer again. Then this substation can feed a medium consumer, medium industry, or it can feed a distribution transformer also. So from this substation, 33 kV or 66 kV is stepped down to 11 kV at the primary distribution side. Then we are having the primary distribution section. It finishes at a transformer, step down transformer again. The 11 kV is being stepped down to 415 or 230 volt. This transformer can supply to consumers requiring 3-phase 415 volt or domestic consumers whose intake voltage is 230 volt. Then from primary distribution substation we are having the primary distribution, and it can feed a 11 kV medium consumer also. So at this transformer, at the end, we are having the secondary distribution from 11 kV to 415 or 230 volt transformer. We are having the secondary distribution section. So from the primary step-up transformer, we are starting the primary transmission. Then the next substation is the secondary transmission substation. Here the voltage is stepped down to 66 kV. The 66 kV voltage section is called the secondary transmission section. It finishes at a primary distribution substation where this voltage is stepped down to 11 kV, and we are having the primary distribution section. Then it goes to a distribution transformer where the voltage is being stepped down to 415 or 230. Then we are having the secondary distribution section. Here it feeds small consumers. This is the one-line diagram of a power system. Various stages from power generation to power reached at the end consumer. Electric power is conventionally generated in large power stations which may be located away from the end consumer. Therefore, it is required to have a transmission system. The transmission system helps to avoid transmission losses. The power generated at the generating station is at a comparatively low voltage, say 11 kV. We have seen this diagram. We shall see the explanation for this diagram in the next slide. Stepping up the voltage level depends upon the distance at which the power is to be transmitted. Longer the distance, higher will be the voltage level. Stepping up of voltage is to reduce the I2R loss in the transmitting of the power. This stage is called primary transmission. Generated voltage 11 kV is to be stepped up to a higher voltage suitable for transmission, that is 220 kV or 400 kV. This is done at the starting of transmission at a substation called primary substation. A step-up transformer is employed for this purpose. The transmission section from primary substation to secondary substation is called primary transmission. At the secondary substation, the voltage is stepped down to 33 or 66 kV. The secondary substation can feed a bulk consumer as well as primary distribution substation, that is high voltage distribution substation. At the primary distribution substation, the transformer steps down the voltage to 33 kV or 11 kV. The primary distribution substation can feed a medium bulk consumer as well as a secondary distribution transformer which steps down the voltage to 11 kV or 450. The secondary distribution substation, that is low voltage distribution substation, steps down the voltage 11 kV to 415 or 230 volt. Hence, both three-phase and single-phase consumers can be fed from secondary distribution substation. This is the one-line diagram of a power system. We have seen the need for transmission, advantages, disadvantages of transmission, and one-line diagram.